Balancing a chemical equation. Why do we need to balance a chemical equation? A chemical equation must be balanced in order for the reaction to comply with the law of conservation of matter. The law of conservation of matter states that matter can neither be created nor be destroyed in a chemical reaction. So, if matter is neither created nor destroyed, then the number of atoms of each element must be balanced both on the reactant side and on the product side. So that is the reason why a chemical equation must be balanced, so that the chemical reaction will comply with the law of conservation of matter. So in general, we are saying that a chemical equation is balanced when the number of atoms of each element is equal on both sides of the equation. The rule is that the number of atoms of each element must be equal on both sides of the equation. If you have two atoms of hydrogen on the reactant side, then we must have two atoms of hydrogen on the product side. That is the only way the equation will be said to be balanced, when we have equal number of atoms on both sides of the equation. Let's see some examples on how to balance a chemical equation. So we want to look at examples on how to balance a chemical reaction. And the first example we're looking at is the reaction that involves the formation of water molecule. Our water molecule has the chemical formula of H2O. Water molecule is formed when hydrogen molecule is combined with oxygen molecule. Hydrogen molecule reacts with oxygen molecule to form water molecule. The reactant in this reaction is the hydrogen molecule and oxygen molecule, while the product is the water molecule. So to represent this reaction, we will write the reactants. We have the hydrogen molecule combining with oxygen molecule. The hydrogen molecule is a gas, and also the oxygen molecule is a gas. So these are our reactants. The two reactants combine to give us our water molecule. The water molecule is a gas if the reaction takes place at 100 degrees Celsius or above 100 degrees Celsius. But below 100 degrees Celsius, then the water molecule is a liquid. So let's assume that the reaction takes place above 100 degrees Celsius. Then our water molecule will also be a gas. So we have our reactant on the left-hand side and our product on the right-hand side. The next thing is to check if this equation is balanced. Remember, we said that a chemical equation is balanced when the number of atoms of each element is equal on both sides. So let's check and see if this equation is balanced. On the reactant side, we can see hydrogen elements, and if we count the number of atoms of hydrogen, we can see that hydrogen is 2. On the left hand side, we have 2 atoms of hydrogen, and also we have 2 atoms of oxygen. While on the product side, we have 2 atoms of hydrogen and 1 atom of oxygen. So the reaction is not balanced because the oxygen atom is not balanced. So we need to balance this equation. So how do we balance this equation? We balance this equation by writing out each atom on both sides of the equation and the number of atoms on both sides of the equation. So on the left hand side, on the reactant side, we have hydrogen atom and we also have oxygen atom. We have two atoms of hydrogen, so we indicate the number of atoms of hydrogen. And we have two atoms of oxygen, we also indicate it. While on the product side, we have hydrogen atom and we also have oxygen atom. We have two atoms of hydrogen and then we have one atom of oxygen. So we said that this equation is not balanced because the number of atoms of oxygen is not equal on both sides. So to balance this equation, we need to start by balancing the number of oxygen atoms, since hydrogen atoms is balanced. And we have two atoms of oxygen on the left hand side and one atom of oxygen on the right hand side. So what we need to do is to have equal number of oxygen atom on both sides. And to do that, we need to multiply this oxygen by a number that will make it equal to what we have on the left hand side. So we multiply 1 by 2. So by multiplying this 1 by a number 2 will give us oxygen atom to be equal to 2. Since we multiply this number by 2, we're going to go to where we have the oxygen atom and add the number 2 in front of the molecule where the oxygen appears. The number 2 is not written below oxygen and it's not written in front of the oxygen because the oxygen is a part of this molecule. Therefore, the number 2 will be written in front of the molecule. By writing this number 2 in front of the water molecule, this number 2 has affected the whole atom that are here. So we need to recount to know the number of atoms of hydrogen and oxygen on the product side. So by checking, we can see that initially we had 2 atoms of hydrogen, but because of these 2 here, we will multiply the 2 atoms by 2. That will give us 4. So hydrogen atom is no longer 2. So this 2 is no longer correct. Our hydrogen atom is now 4. While our oxygen atom is 2. We have 1 atom, when we multiply it by this 2, it gives us 2. Now, on checking both sides of the equation, we can see that the oxygen atoms are balanced, they are equal, but the hydrogen atom is no longer balanced. We have 2 atoms on the left hand side and we have 4 atoms of hydrogen on the right hand side. So we need to balance the hydrogen atom. We do that by asking ourselves, what number are we going to multiply to the atoms on the left hand side to have it to be equal to what is on the right hand side? So we'll multiply these 2 by a number 2. So by multiplying 2 by 2 will give us 4. So because we multiply our hydrogen atom by 2, we will put this number 2 in front of where the hydrogen atom is. So this number 2 will be placed in front of the hydrogen molecule. So this hydrogen 2 is only affecting the hydrogen molecule. It's not affecting our oxygen molecule. So we need to check again to see if the equation is now balanced. On the left hand side, we have 4 atoms of hydrogen and 2 atoms of oxygen. While on the right hand side, we have 4 atoms of hydrogen and 2 atoms of oxygen. So the equation is now balanced because we have equal number of atoms of each element on both sides of the equation. So what is this equation saying? This equation is saying that in the formation of water molecule, there are 2 molecules of hydrogen. This number 2 is called the number of moles or the number of molecule. So 2 moles of hydrogen combined with 1 mole of oxygen. It is 1 because the coefficient of this oxygen molecule is 1. So 2 moles of hydrogen molecule combined with 1 mole of oxygen molecule to give us 2 moles of water molecule. So that is the interpretation of this chemical equation. Let's see another example on how to balance a chemical equation. The second example we are considering is the reaction involving the decomposition of potassium triisocyanate 5. We want to write a chemical equation involving the decomposition of potassium triisocyanate 5. So potassium triisocyanate 5 has the chemical formula of KClO3. So this is the chemical formula of potassium triisocyanate 5. And the decomposition of potassium triisocyanate 5 gives us potassium chloride and oxygen molecule. So in this reaction, our reactant is the potassium triisocyanate 5, which is being decomposed to give us two products, the potassium chloride and the oxygen molecule. So let's represent this reaction using a chemical equation. So we say that our reactant is our potassium triisocyanate 5, which is a solid. So the reactant is a solid. This reactant undergoes decomposition to give us potassium chloride, which is also a solid, and oxygen molecule, which is a gas. So we have our equation. So the next thing is to check if this equation is balanced. On the left hand side, which is our reactant side, we have one atom of potassium. On the right hand side, we have one atom of potassium. So the potassium is balanced. We have one atom of chlorine on the left hand side. We also have one atom of chlorine on the right hand side. The chlorine atom is balanced. We have three atoms of oxygen on the left hand side, but on the right hand side, we have two atoms of oxygen. So the oxygen atom is not balanced. So therefore, this chemical equation is not balanced. We need to balance this chemical equation. So to balance this chemical equation, we start by writing out the atoms of each element and the number of the atoms of each element that we have on both sides. So on our right hand side, we can see we have potassium, we have chlorine atom, and we have oxygen atom. We have one atom of potassium, we have one atom of chlorine, and then we have three atoms of oxygen. On the right hand side, we also have potassium, chlorine atom, and oxygen. We have one atom of potassium, one atom of chlorine, and two atoms of oxygen. So we need to balance our equation. We'll start by balancing the oxygen atom that is not equal on both sides. So we'll ask ourselves, what are we going to do to this oxygen atom to make it balanced? Or which number are we going to multiply to both sides to make the number of oxygen atom to be equal? So on our right hand side, we can multiply our oxygen atom by the number 3. So that 2 times 3 will give us 6. So in order to get 6 on the left hand side, we also need to multiply this number 3 by the number 2. So by multiplying our 3 by 2 will give us 6. So we now have 6 atoms of oxygen on both sides of the equation. Now remember we said that if we multiply by 2, then we will indicate it by writing 2 in front of where the oxygen atom appeared. So these 2 will be written in front of the potassium triisocyanate 5 because oxygen is a part of this compound. And also, because we multiply the oxygen here by 3, we also indicate it by writing 3 in front of where the oxygen molecule is. Now, these 2 that we have put in front of this compound has affected the number of potassium, chlorine, and oxygen. So we need to recount our atoms again. So on our left hand side, the potassium is 2. So we no longer have one atom of potassium, but rather we have 2 atoms of potassium. And also the chlorine atom is now 2. So this is no longer correct. We have 2 atoms of chlorine, and then we have 6 atoms of oxygen. That's these 2 times this 3 will give us 6 atoms. Let's go to our right hand side to count the number of atoms. We have one atom of potassium, one atom of chlorine, and then we now have 6 atoms of oxygen. So looking at both sides of the equation, we can see that the equation is not balanced because our potassium and chlorine is no longer equal on both sides. So we need to balance our potassium and chlorine. So we need to multiply this 1 by a number that will make it to be equal to 2, and that is by multiplying to the number 2. So by multiplying 1 by 2 will give us 2. The same thing applies for chlorine. We have 2 atoms of chlorine on the left hand side. So we need to multiply this 1 by the number 2 so that it will also give us 2. So now we can see that both of them are equal. Now remember, because we multiply by 2, we're going to add the number 2 in front of the compound where our potassium and chlorine is present. So we have put 2 in front of potassium chloride. So by so doing, we can now see that this equation is now balanced because we have equal numbers of each atom of an element present in this reaction. So this is how to balance a chemical equation. We have been able to see 2 examples on how to balance a chemical equation. I believe that with these 2 examples that we have solved, you can be able to balance a chemical equation. So if you have enjoyed this video, please click on the like button and don't forget to subscribe to our YouTube channel to get notification whenever we release new video. So see you in our next video.